Today we are going to learn aromaticity, aromatic hydrocarbon, the part of organic chemistry, right? Part of organic chemistry which we are going to deal is aromatic hydrocarbon. This is your unit number 05. So one by one we will discuss all the unit, and based on that you will have one test on Sunday. So you have to appear for the test and see how much concept you have gained. Okay, and if you have any kind of doubt, you can ask me anytime. Okay, I'll reply you, okay, through my WhatsApp or maybe in this app chat box you can ask. So okay, so let me start. So welcome to GChem classes. So today we are going to deal the aromatic hydrocarbons in that aromaticity. Okay, in this unit it consists of aromaticity. First it starts with aromaticity, that is Huckel's rule. Okay, so if you see what is aromaticity, if we discuss the aromaticity, so how you are going to define the aromaticity? Okay, the syllabus this time they make it vast, correct? Otherwise it was like in one pager syllabus, but now they have specifically mentioned that what all they are going to ask, right? So based on that you have to study. Okay, 1 second. Batches CUET PG English. One more student is there, want to join. Okay, yeah. So suppose we are defining aromaticity. So aromaticity means it should follow the Huckel's rule. Finally, it should follow the Huckel's rule, correct? So in this, it is included aromaticity, anti-aromaticity and non-aromaticity, right? Aromatic, anti-aromatic and non-aromatic. So one by one we will see it. Let's see. First we'll see what is aromaticity. Aromaticity means it should be cyclic. The molecule should be cyclic. Cyclic means what? If suppose this is carbon number 1 and carbon number 2, carbon number 3, okay, if this 3 and 1 is connecting, then we call it cyclic. So it means the initial carbon, the carbon number 1 and the final carbon, whatever the carbon number, whether it's the 5th, 6th, 7th, whatever is the number, we call it, if it is getting connected with the first and the last, we call it, it's a cyclic compound, correct? So it should be cyclic. Second, it should be planar. Okay, so how you are going to define the planarity? Okay, so what is the process to define the planarity for any type of molecule? Whether this molecule is planar, if I am drawing this one, CH2, 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 you have option A, you have option B, CH2, CH, 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 okay, double bond, and here it will be CH minus, okay, correct? And one more I'll take CH plus CH double bond CH. So now this option A, option B and option C. So if I'm asking you which one will be the planar, option A, B or C, it can be a multi-selection question, okay, or it can be a MCQ. So just let me know which one is a planar. See, for cyclic we have already defined that first carbon, suppose this is the first carbon, first, second, third. So third and first is getting connected. Here also 1, 2, 3. So first and third is getting connected. Here also 1, 2 and 3. First and third is getting connected. So this is a cyclic molecule. No doubt this is a cyclic molecule. So first point it is satisfying, right? First point it is satisfying that this is a cyclic molecule. Now the next question is, like our next point is, it should be planar. It should be planar. So how you are going to define the planarity? Whether the option A is planar or B or C. See, this class make it an interactive kind of thing, okay? So I'm just waiting for your reply. Just reply me whether it's a planar. Which one is a planar? A, B and C. Which molecule is a planar? Okay, just reply. Make it a two-way, okay? So if session is more interactive, then you will gain more knowledge. Otherwise it will be simply if you are seeing only, then it will be a recorded type of classes, right? So whether you are attending live class or not, it won't be beneficial. So better you interact it. Whatever doubt you have the chat section here, you just write up. Okay, now the question is whether A, B, in this, out of these three, A, B and C, which one is planar? Which one is planar? Then only we'll go for next question. Okay, how the question is raising, we'll see. So first you answer it, which one is planar. Okay. Okay. Maybe are you audible? Are you audible to me? If you are audible, then type yes. Okay. Maybe my sound is not reaching to you. Just if you are audible, then just reply yes in a chat section. Just reply yes. Am I audible? I should be audible. It is not like that because this is not a first class. Okay, so it should be audible. Okay, how to find the compound is planar, sir? So that is the question. So that's why, see, if you are replying, then only I'll come to know that in which direction I should go and I should treat you, right? So now I come to know. First I have to define the planarity, correct? So planarity means it should be in a plane. Okay, it should be in a plane. Like, see, this is your syllabus, right? For CUET syllabus, where we are seeing aromatic hydrocarbons, right? So this page, what we call, this page is a planar, correct? Now this plane is planar. How this is planar? Because it is having only x and y coordinate. It's having only x and y coordinate. So this is a planar. If apart from that x and y plane is there, suppose this is like this page, if this page is not straight, okay, see, if you are seeing like this, see, if this page is not straight, if it is like this, then it is not planar. Okay, it is not planar. So now how to find the planarity? We'll see. If this molecule you are seeing, this is sp3, this one is sp3, this one is also sp3, and we know that sp3 is tetrahedral. sp3, what is the geometry? Geometry is tetrahedral, means it will be something like this. It will be something like this. Hydrogen, 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 or carbon, whatever you want to add. So this is a tetrahedral. So this is not a planar. It is not a planar, means it is not having x and y. It's having x and y. Along with that, it's having z axis also, right? Along with the x and y, if you have z axis also, then we call it, it's not a planar molecule. Okay, if it is having only x and y plane, then we call it, it's a planar, correct? So till 2 dimension we call it a planar. After that 2 dimension, if it is going to 3 dimensional, it won't be planar. So this is a tetrahedral molecule. How it will look? It look like a samosa kind of thing, right? So samosa, front 3 you can see this one and this one. These 3 you can see in front, and this hydrogen will be in the back side, so that the samosa can sit, right? So that the samosa can sit. So now this is not a planar molecule. This is a tetrahedral, so this is not a planar molecule. Now come to the point. In this place, this CH is your sp2. So if it is sp2, means sp2 carbon. Okay, sp2 carbon. This is also sp2, and this one is 1, 2, 3, and 1 negative is there. This one is sp3. So now we'll see whether this is a planar or not. Okay. Likewise, here also it is sp2. I'll discuss it. Let me draw it first. This is also sp2, and this is also sp2. Means here all the carbon are sp2, and if sp2 hybridization is there, then molecule will be planar, right? It will be like, suppose we have boron, hydrogen, hydrogen, and hydrogen. This boron is sp2, right? So how it will look? It will look like simply a triangle parota. It will look like simply a triangle parota. It means it will have x direction and it will have y direction. It won't have z direction. Means it will be simply in a plane. Okay, it will be simply in a plane. Okay, so this will be your sp2. So it means wherever you will find sp2 hybrid carbons, those are a planar molecule. Those are a planar molecule. It won't have z direction. It will have x and y plane. It's only correct. So here the geometry is trigonal planar. Okay, when we will we have not dealt that hybridization chapter, we will deal it the hybridization chapter also. So now here we'll see the aromaticity. In that, this is a trigonal planar. So likewise, this sp2 is also trigonal planar, trigonal planar, trigonal planar. Means this option C is planar. Okay. Why I went directly from A to C? It is having something. We'll discuss for the B because it is little bit tricky. Okay, this one is little bit tricky. That's why I want to discuss it in last. So now, have you understood for the option C? This is a planar because all are sp2. What is happening? This bond is shift here, then this positive will get neutral and the next positive will generate here. Again this double bond will shift here, this positive will shift here, and whatever the double bond is there, it will shift here, right? So likewise it will move, correct? For this kind of thing, this option B, option A is not a planar, okay? Now coming to the option B, what is happening? This is sp3, so we know that sp3 is not a planar, it is tetrahedral, right? sp3 is a tetrahedral, but in this situation, in this type of case, this whole molecule is a planar. Okay, this whole molecule is a planar. If you are considering only carbanium, if you compare these two, okay, if you compare these two, CH3 minus and this molecule CH minus and then CH double bond CH. If you compare these two, okay, this is option B and maybe this is option D. If you compare these two and if I'll ask that which molecule is planar, you will say that this carbanium is not a planar because this is a tetrahedral. Okay, this is a tetrahedral. What about this one? Here also this is carbanium, so it should be also tetrahedral, but then it is wrong. It is not a tetrahedral molecule. Overall, this molecule is a planar. So how it is planar? Let's see. So that is the concept. We'll see how it is planar. Okay, we'll discuss it here. So now we are just discussing the second point, planarity. Okay, we are finding the planarity concept. Okay, so now take this molecule CH minus and then CH double bond CH. Okay, so in this carbanium, what is happening? This negative charge is localized. What we call this carbonyl charge is localized. We use the concept, we use the term localized. Localized means it will be stable. That carbanium will be available in that carbon in all the time. Okay, in all the time this negative charge will be available in that carbon, and due to that this will be your sp3 and the molecular geometry will be tetrahedral. Shape is pyramidal, okay, trigonal pyramidal, but geometry will be tetrahedral. Geometry will be tetrahedral. How you are finding? Just we know that for hybridization we are calculating steric number, that is 1 by 2 valence electron. How much valence electron is there? Carbon it is 4. How many monovalent are there? 3 hydrogen is there. And then if it is negative, we are adding 1. If it is positive, we are subtracting. Okay. So now what is happening? 4, 3, 7 and 1, 8. 8 by 2. So it is coming 4. 4 means it is sp3. Right? If you were following my YouTube channel's video, you know this, right? We already discussed their hybridization and all, correct? But don't worry, this is your paid classes. So I will discuss everything and I will make sure each and every concept will get clear. Okay? Because it is required very much, otherwise it will be difficult. Correct? Now coming to the point, this one is sp3 and sp3 we know that geometry is tetrahedral, shape is trigonal pyramidal. Correct? Now this negative charge is localized. If it is localized, it won't move anywhere, so it won't give you planarity. Now coming to this point, we know that this is sp2, this one is sp2. Now what is happening? This negative charge, whether this is localized or not. Okay, just you think and let me know whether this negative charge is localized or not. My question is whether this is localized or not. This negative charge is localized or not. Just answer me whether this is localized or it's a movable. Like this carbocation, it is movable, right? This double bond is shifting here, then carbocation is moving this side, then again this double bond is shifting here, then again this carbocation is moving this side. So whether the same condition is applying here or this negative charge is localized and fixed in that carbon. Localized means it is fixed in that particular carbon. Likewise, this carbanion. Okay, in this carbanion, what is happening? This negative charge is localized in that particular carbon. So whether this negative charge is localized means it is fixed in that carbon, or it is delocalized. Okay, good. It is delocalized. Now you understood, right? So now what will happen? This will shift here and this will move here. Okay. Next, what will happen? See, CH, double bond, CH, and then your CH and negative charge. Again, what will happen? This negative charge will move here. Okay. And this will be coming here. So again, what will happen? CH negative charge, and then CH, and then double bond is moving here, right? So this one. Next time, whenever this double bond will be shifting here, this negative will shift here, and this will be shifting here. So this will go and you come to the starting point, right? Your initial molecule. So 1, 2, 3, three contributing structures you are getting. So due to this delocalization, this negative charge, this won't be contributing in your hybridization. So this is a planar molecule, right? This negative charge is not localized. So that's why this molecule is also considering as a planar molecule. So this is only one example. If this kind of a molecule is also there, here also you have to see this negative charge. This is also your planar molecule, because this negative charge is shifting here, this will go, this negative will come here, again this negative will go there, this one will be shifting here, again next point this will be shifting here. Okay, likewise it will just delocalized. Okay, it won't be localized. Whenever, just now you should know the point. It is if we have alpha beta unsaturated carbanion. Okay, alpha beta unsaturated carbanion. Okay, this is carbanion alpha beta. So alpha beta unsaturation carbanion, if you are having, it will be delocalized carbanion. It won't be localized, and if it is not localized, it won't be sp3. It will be a planar molecule. And if it is alone, if you don't have alpha beta unsaturated carbanion, then it will be localized. Suppose in this case, if I draw this molecule and if I'll ask, tell me whether this molecule is planar or not. This molecule, I am talking about this molecule. Tell me whether this molecule is planar or not. This molecule is planar or not. Here one double bond is there, and one here one negative charge is there. Whether this molecule is planar or not. Whether this molecule is planar or not. Just I'll number it. This is carbon number 1, this is 2, this is 3, this is 4, and this one is 5. So whether this molecule, this carbanion molecule, cyclic carbanion, is a planar or not. Whether this molecule is a planar or not. Okay, I'll rub it and I'll draw it. Okay, I'll just leave that structure alone. Remaining I'll rub it. Okay, just let me know whether that molecule is planar or not. I'm talking about this molecule. Okay, planar. Okay, you are saying planar. How you are saying planar? Just see this molecule. How this one you are saying planar? How you are saying this is planar? What is the concept you have applied? So this is the under number. I'm numbering. I'll do the numbering 1, 2, 3, 4, 5. Okay. Now I'll rub that structure. Okay. So now you just tell me the same structure I have drawn here. How it is planar? At what conceptual basis you are telling this molecule is a planar? At what conceptual basis? What you have applied? Okay. Just let me know. See, whatever in your mind, you just express it so I can clear it. Correct? Whatever is your doubt, okay, whatever concept you have applied to say this molecule is planar, just let me know. I'll clear that concept for you, right? And next time you won't be confused. Next time you won't be getting confused. See, if you are thinking that this will be migrating here, Now you just see, I'll just open up and write this structure. You need very much basic thing. So suppose if I'm writing CH negative, then here or this way also I can write it. This way also I can write it. I'll just do this molecule again, I'll draw it, and then this is a double bond. So one hydrogen, this side one hydrogen, here one hydrogen, hydrogen, and this one is negative. So only one hydrogen will be there and negative charge will be there. Correct? So these two are similar. So arrow I won't give, I'll just write like this. So these two are similar. Now you see, this carbon is sp3. This carbon is also sp3. This carbon is also sp3. This carbon is sp2. This carbon is sp2. Correct? These two, maybe it is in planar. Okay, these two carbon. But what about this three? See, this carbonyl cannot be moved this side because unsaturation is not there. If this is moving this side, what will happen? Just see what will happen. It will be, okay, already two hydrogen is there. You are shifting one carbanion here. Okay, this carbon, for this carbon 1, 2, 3, 4, it is satisfied. Think about this carbon 1, 2, 3, 4, 5. So 5 bond, whether it is possible 5 bonds. Whether it is possible 5 bonds. If you are thinking we will move this side, see two hydrogen, and it has shifted this side. See the count the bond 1, 2, 3, 4. For this carbon it is okay. For this carbon 1, 2, 3, 4, 5. How many bonds? 5 bonds it came. Whether it is stable, it is possible. Carbon is having valency only 4. It can make only the bond 4 bond, correct? So now what is happening? See, I told you it should be having alpha beta unsaturated carbanion. Okay, this is not alpha beta. See, this is alpha, this is beta, this is gamma, and if you are writing, this is delta. If you are coming from this side, this will be alpha, this will be beta, this will be gamma, this will be delta. So this is beta gamma unsaturated, right? This is beta gamma. But what we need alpha beta unsaturation. Suppose if this double bond is here, then it can be possible. Because this will shift here and this will shift in here, right? Correct? So, but in this case, we have double bond here. So it is not a alpha beta unsaturated carbanion. If it is alpha beta unsaturated carbanion, then only it can delocalize. If it is not a alpha beta unsaturated carbanion, then it won't be delocalized. It will be localized in this particular carbon. So this will be sp3, and we already have this one sp3 and this one is also sp3. If it is sp3, it will be tetrahedral, then it won't be planar. So this molecule is not a planar molecule. Suppose directly if they are asking this, tell me the planarity of this molecule, be careful. Okay, just try to draw the resonance. If resonance is possible, then that molecule is planar. If resonance is not at all possible, that molecule won't be planar. Correct? Is that clear? Or you have any kind of doubt? If you have doubt, let me know. I'll just make you understand. Okay? If you have doubt, let me know. No problem. Okay? Whatever the wrong thing is that you can express it here. Whatever. You can express it here. Okay? We will refine it and again you will get the correct thing. Okay? So, going forward you won't be misled, or going forward you won't be a confused person, right? You will be a clear-cut chemistry student, right? So, whatever exam you will appear, it will be good for you. So, initially 1 or 2 classes, what we will do, we will go very slow, because see, you are like, this is your initial classes, right, with me. So first what we should have, the rapport should be developed with the teacher and the student, right? If that rapport is not there, then it will be simply a YouTube class, right? So whatever you are just searching, randomly you got one class and you are just taking those classes. It should not be like that. First, this student and teacher, these two rapport should be developed, and once it is developed, then only whatever in your mind you will just express it, and the same time I'll just answer your question. So in that way we will be discussing our entire organic chemistry, then inorganic, then physical. Okay, so whatever you are learning, every Sunday you will have one test. Okay, whatever till like whatever syllabus we will complete it till Saturday. Sunday you will have test for that particular things, and then you can evaluate where are you standing. Correct? So because that is very much required, that evaluation part is very much required for your learning process, right? So we have only clear two things. One is it should be cyclic. Second, it should be planar, and then directly you added all the carbon should be sp2 hybridized. Okay, all the carbon should be sp2 hybridized, because we know that if it is sp2 hybridized, this will be planar. Okay, so these three we have already fulfilled, and third one we already seen that this the migration of negative charge is happening, right? Delocalization of negative charge is happening, delocalization of pi bond is happening. So what we call those, it will be a conjugation. Conjugation should be there. Conjugation should be there. If the molecule is planar, conjugation will be continue. If the molecule is not planar, conjugation will stop there. Okay, then and there it will stop. So see, this is sp3, this conjugation is stopped here. Correct? This conjugation is stopped here. So the complete conjugation is not available. So now conjugation is also required. Okay, after this 4, one more rule is there. That is, we call it 4n plus 2 pi electron. Correct? This is your aromaticity. This 4 point will be same for aromatic and anti-aromatic. Okay, this initial 4 point will be same for the aromatic and anti-aromatic. So directly now we are moving towards the, if you see your syllabus in aromaticity, it is aromatic character of arenes. So now we will moving towards the aromatic characters of arenes. Okay, once that will be completed, already we have taken this carbanion part, the relocalized one, that also you have to see, that is called cyclic carbocations and carbanions. Okay, that also we will discuss it. That also part of arenes only we will do it. So now this rule, if this rule it is following, this will be aromatic. If this rule is not following, one more is there, 4n pi electron. If this rule is following, this will be anti-aromatic. Okay, anti-aromatic. Remaining 4 will be same. The fifth one will be 4n pi electron, then it is anti-aromatic. If fifth one is 4n plus 2 pi electron, then it is aromatic. So this you have to just see whether, first you have to find it out whether it's a cyclic, whether it's a planar, whether it's a sp2 hybridized, whether conjugation is possible or not. If everything is fixed, then you have to come for 4n plus 2 pi electron system or 4n pi electron system. If it is following 4n plus 2 pi electron system, it is aromatic. If it is following 4n pi electron, then it is anti-aromatic. Let's see. One example we will see. Okay. Then we will discuss the concept. We will discuss the examples, because examples discussion is required more. Okay. So don't worry. Now 1 or 2 classes will be very much slow, and after that we will start taking up much more syllabus in a single day. Correct? Because this, as I told you, this rapport should be required, student and teacher. Okay, when you will able to understand my language, okay, the teaching language, then only you will get more. Correct? So now for aromatic, if we will say, suppose this is the molecule. Okay, suppose this is the molecule. Simply I will draw benzene. Okay, simply I will draw benzene. Whether this molecule is cyclic or not, first I will just write it down. Carbon number 1, 2, 3, 4, 5, 6. Simple. Okay. So carbon number 6, the last carbon and first carbon is connected. So this molecule is cyclic. Okay. Now the second point, whether this molecule is planar or not. See, this molecule is planar. Why? Because this is also sp2, 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 sp2. All are sp2. So this molecule is planar. Now sp2 hybridized. All are sp2 hybridized. Okay, all are sp2 hybridized. So I'll say whatever example you are getting, initially at least 10 or 20 examples, you just write it down like this, okay? I know it will take time, but it will be perfect. So what will happen? You will be remember all those points, correct? So whatever example you are solving initially 10 or 20, see this, whatever I am saying, this I am considering that the learner is just starting aromatic hydrocarbons, correct? If you know very well the aromaticity, then it is not for you, correct? Otherwise, I'm just thinking that the whoever is sitting other side, those students need from a basic, okay, from the basic, correct? So now you just see sp2 hybridized. Now conjugation is possible or not? See, if this one is moving here, here the positive charge will develop, so this will come here. Then again positive charge will develop here, this will come here. So see, the conjugation is available. If I draw the conjugated structure, it will be, see, this bond is shifting here, then this bond has shifted here, then this bond is shifted here. See, again it is aromatic only. Everything is planar, everything is perfect. Now we have to see whether it's following 4n plus 2 or 4n pi electron. How you are going to calculate this 4n plus 2 or 4 pi aromatic system. So before that, you have to see 1, 2, 3. How many pi bonds? 3 pi bonds are available, and you know that 3 pi bonds, 1 pi bond is having 2 electron, right? 1 pi bond is having 2 electron. How pi bond is forming? It is a lateral. See, this is sigma bond, head to head overlap, and pi bond is lateral overlapping. So 1 electron here, correct? And 1 electron in this down. I am talking about this down. 1 electron is here in this carbon, and in adjacent carbon 1 electron is in down. So this upper electron will jump, and this down electron it will jump, right? So it will look like, okay, electron cloud, correct? So it will look like electron cloud. So now you just see 3 pi bonds means 3 into 2, total 6 pi electrons. How many electrons are there? 6 pi electrons. Now just we have to see one by one these two formula where the 6 pi electrons is coming. So now 4n plus 2 pi electron. Here the n value is starting from 0, 1, 2, 3 and it will go till infinity. What about 4n plus pi electron? The n will start from 1, 2, 3 until it will go to the infinity. That you have to keep in a mind. So it will start from 0, it will start from 1. So now this formula we will take it first. 4n plus 2, okay, pi electron. In that the first value 0 we will put it, 4 into 0 plus 2 pi electron. How much it is coming? 4 into 0 is 0, so it is coming 2 pi electron. Whether this is a 6 pi electron, a 2 pi electron? No. So next we will see, we will put the n value until the value is exceeding to the 6, okay, or it will be equal to 6. We have to see till the 6 or exceeding to the 6, correct? If it is matching with the number 6, then it is aromatic. If it is not matching, then we will take this formula and we will continue until we will reach the matching value, correct? Now you just see 4 into n value we have taken 0. Now we will take 1 plus 2 and then pi electron. So it will be 4 into 4. 4 into 1 is 4, okay, plus 2, okay, how much it is coming? 6 pi electron. See, this number is very much matching with this number 6 pi electron. So it means this molecule is following this rule. So this is a aromatic, and you know this is a very simple example I have taken. So now I'll just change the example and we'll see one by one. We'll see. So this is a benzene. Suppose we are taking this molecule. Now whether this is a aromatic or anti-aromatic, we'll see. See, this is a cyclic. No doubt this is a cyclic, correct? Cyclic. This is a planar because this is sp2, 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 sp2. All are sp2 hybridized. Conjugation is there. See, if it is going there, it will come down. So what will be the next structure? Structure will be like this. Again, what will happen? This will be going there, this will be coming here. So this bond will be coming like this, correct? So these are the contributing structure. So conjugation is also there. So all the 4 points it is following. Now we have to see whether this is following 4n plus 2 pi electron system or 4n pi electron system. If it is following 4n plus 2 pi electron, this is aromatic. If it is not following, it is following 4n pi electron, then this is anti-aromatic. Now we will see. First we have to calculate how many pi bonds are there. 2 pi bonds are present. So how many electrons? It will be 2 into 2, 4 pi electron. Okay, how many electrons are there? That you have to calculate 4 pi electron. So you know this one is aromatic, right? So actually I am taking very much from the initial. Okay, I want to clear all the concepts. So likewise, if you are replying fast, then what will happen? My classes will also move faster, right? So that's why I am telling it, make it interactive. So because I have to know, right, where you are diverting or where you are catching. So everything I have to know, then only I can give you the better conceptual syllabus, right? So 4n plus 2. So how it will happen? See, 4n. First we will take 0. So 4 into 0 plus 2. How much it is coming? 2 pi electron. This is not 2 pi electron. Now 4n plus 4 into 1. We will take it 1 because after 0 we will take it 1 plus 2. So how much it is coming? 6 pi electron. Now you see it is exceeding. The number 6 pi electron is exceeding. So we will go for the next formula. 4n pi electron. So 4 into, here 1, n will start with 1, right? So 1. So 4 into 1, how much? It is 4 pi electron. So now see, the 4 pi electron and this 4 pi electron is exactly matching. If it is exactly matching, then what will happen? This is our anti-aromatic. What is this? Anti-aromatic. So these are the arrange system you are calculating, arrange system. Now you just tell me this one, whether this is a aromatic or anti-aromatic. Whether this is a aromatic or anti-aromatic. Now you just tell me, because one by one just write it. It is a cyclic. Yes, this one is cyclic. Next question is whether this is a planar. Now question is arising whether this is a planar, because this oxygen is having 2 alkyl group. If we will take dimethyl ether, it is just similar to that, right? If this fragment only I am talking, if I am talking only this fragment, this much fragment, if I am talking about only this much fragment, so it is resembling to dimethyl ether. Now for this dimethyl ether, whether this oxygen is sp3 or sp2 or sp, just let me know. Whether this, just you tell me for this oxygen, whether this is sp3 or sp2 or sp. You just tell me. First you tell me for this and then we'll directly go there, okay? Because you should know from the basic, right? Why the things is happening. Just don't mug it up. Whatever you will mug it up in chemistry, you will forget. Okay? It won't be everlasting. If you want your concepts should be everlasting, you should be thinking in this type of style, right? Correct? So just tell me whether this oxygen is sp3, sp2 or sp. Whether this oxygen is sp3 or sp2 or sp. How you are going? Okay, you know that this is also resembling with, if you are not able to finding out, this is also resembling with your water. Because here alkyl is there, here hydrogen is there, here alkyl, here hydrogen. What about hybridization for water? sp3. Now you will say that sp3. See, whatever hybridization, if I am asking or anyone is asking, or in your examination if it is asking, simply you just put this formula, no, 1/2. First find the steric number, based on steric number you find the hybridization, and then shape and geometry, correct? So now 1/2 valence electron for oxygen, what will be the valence electron? Just tell me what will be the valence electron for oxygen. How you are going to consider this? This you know sp3, right? If suppose this won't be there, if they are asking this one, so how many monovalent? 4. Okay, steric number 4 you are telling. So I am not going to calculate. So 4 you are telling, because 6 plus how many monovalent are there? 2. There are no negative, no positive charge. So 6 plus 2, 8. 8 divided by 2, it is 4. So 4 means it is sp3. sp3 means it will be your if sp3 means it is a tetrahedral means it won't be planar. Now you come to this point. Okay, we were discussing this molecule. So for this molecule, I'll just rub this side. We will draw the aromatic or anti-aromatic or whatever is there. So this molecule is aromatic or anti-aromatic. See, here what is happening? This lone pair is there, right? So see, again, this is a alpha, this is beta. Alpha, beta, unsaturated, and here in this heteroatom we have lone pair. So what will happen? Again, delocalization of lone pair. But in this case, this water, this lone pair are localized. This dimethyl ether, this lone pair are localized. It is not delocalized. If it is localized, then only the hybridization is coming sp3, the geometry is coming tetrahedral, the shape is coming bent. Correct? Likewise, here the lone pair, what is happening? This lone pair is contributing towards the conjugation. So our first is cyclic, second is planar. Why planar? Because this lone pair is shifting here, this will go here and this will come in here. So the conjugation is continuing. Conjugation is continuing. It is not stopping. Your conjugation is not at all stopping. So we have sp2 and then we have conjugation. You got it? We have conjugation. So now if I'll say that how many pi electrons are there, so you have to consider this lone pair. You are not going to consider this lone pair too, because if you are considering this lone pair, then it will be wrong, because this lone pair is not at all participating in your conjugation. Only this particular lone pair, only single lone pair is this lone pair only participating in your conjugation, not this one. Correct? So we are not going to consider. So now 2 pi bonds, here how you are writing? 2 pi bonds plus 1 lone pair, because lone pair is contributing. If this lone pair is not contributing, we are not going to write the lone pair, right? If it is contributing, we will write this lone pair is contributing, right? So now 2 pi bonds plus 1 lone pair. So how many are there? 2 pi bonds contribute 4 electrons and 1 lone pair contribute 2 electrons. So total 6 pi electrons. We'll say 6 pi electrons. Total 6 pi electrons we say. Overall 6 pi electrons. Okay, now you are telling it's aromatic. Good. Now it is aromatic because it will 4 into 1 plus 2, so it will be 6 pi electrons and it is a aromatic. Now you just tell me this one, whether this is a aromatic or anti-aromatic, and you just tell me this one. Okay, this is A, this is B. Just discuss it. Which one is aromatic and which one is anti-aromatic? Okay, non-aromatic means any of the following will be not followed. Okay, maybe the molecule is not cyclic, maybe the molecule is having sp3 hybrid, maybe the molecule is not planar, maybe the molecule is not having conjugation, maybe the molecule is not at all following 4n plus 2 pi electron or 4n pi electron system. Okay, if these are the case, then we say that that is a non-aromatic, correct? But anti-aromatic, all the 4 points should be similar, only the 5th point will be changing for the aromatic and anti-aromatic. For aromatic it will be 4n plus 2 pi electron. For anti-aromatic it will be 4n pi electron. So A and B, just tell me what is A, whether A is aromatic, anti-aromatic, whether B is aromatic or anti-aromatic. How you are going to find it out? Just tell me. First you have to see whether it's a cyclic. Yes, this one is cyclic. Second, whether it's a planar. Yes, it is a planar. Third, whether all are sp2. Yes, all are sp2, because this is also sp2 carbocation. How you are going to calculate? 1/2 valence electron 4 plus 1 2 3. 3 bonds are there. Okay, 1 hydrogen will be there, right? Nothing is there means 1 hydrogen will be there. So 3. And if cation is there, we are doing minus, right? So 4 plus 3 7 minus 1 6. 6/2 it will be 6/2 it will be 3, and steric number 3 means it will be sp2. So now this is also sp2. This is sp2, 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 sp2. All are sp2. And conjugation, whether conjugation is there or not, see conjugation. This moved here, positive charge develop here. This will move, positive charge will develop here. Again this will move, positive will develop here. Again this will move, positive will develop here. So the conjugation is also there. Okay, so conjugation is also there. Now we have to see whether it's a 4 pi plus 2 pi electron or 4n pi electron. Okay, we'll see. So first 4n plus 2 we will see it. So 4 into 0 equal to 0 plus, so it will be 2 pi electron. How many pi electron are there? First we will calculate 2 or 2, 4 pi electron. Okay, so now just we have to consider this one. Again 4 into 1 plus 2 means it will be 6 pi electron. So it is exceeding to the 4 pi electron, so it is not a aromatic. We'll see 4 into 1. Okay, 4 into 1 pi electron, so it means 4 pi electron system. So this is a anti-aromatic. AA is anti-aromatic. What about this one? We'll see see 2, 2, and this is a delocalized negative charge. So negative charge will contribute 2 electrons. So 2, 2, 2, total 6 pi electron. Okay, so 6 pi electron, planar, cyclic, conjugation, sp2, everything is possible, and it is following 4n plus 2 pi electron system. So this is a aromatic. This is a aromatic. So likewise they will ask question. I'll give you few questions and then I'll stop for today. Okay, I give you few questions. You just, as an assignment, you just, like it's a kind of DPP, you just solve it and you upload it. Okay, through WhatsApp or through this chat also you can send me. Okay, just draw it in a paper and then you just send it to me. Correct? So these are the few questions I am giving you. You just tell me whether this is a aromatic, anti-aromatic, or your, what we call. These are the simple molecule. You have to just find it out whether it's a aromatic, anti-aromatic. Okay. Okay. Just draw it in your paper and then you just send it to me. Okay. We'll see whether it's a aromatic or anti-aromatic or. Okay. Oh, this much only. 1, 2, 3, 4, 5, 6, 7, 8. 8. Okay, till H. You just draw it in your paper and then you just tell me whether it's aromatic, anti-aromatic or non-aromatic. Okay, aromatic, anti-aromatic or non-aromatic. Aromatic, anti-aromatic and non-aromatic. Okay, just draw it in your paper and then you just reply me. Okay, so I'll just see your concept, how much you have gained. Okay, and appear for the test in the upcoming Sunday. Okay, it will be beneficial for you. So we have covered today Huckel's rule, aromaticity Huckel's rule, aromatic characters of adenes, cyclic carbocation. Okay, cyclic carbanion also we have seen, and heterocyclic compounds. We are starting just heterocyclic compound. We have just seen the furan. Okay, likewise we'll just take it. So heterocyclic compounds also with suitable examples. Okay, we have seen. Now next we will discuss it next class, electrophilic aromatic substitution. Okay, electrophilic aromatic substitution. In that, halogenation, nitration, sulfonation and Friedel-Crafts alkylation, acylation with their mechanism. Okay, so I think 2 or 3 class it will get complete. 2 or 3 class it will get complete. So your syllabus, they have make it like in organic chemistry. How many units are there? You just see organic chemistry. They have 16 units. Okay, organic chemistry 16 units they have. Physical chemistry they have physical chemistry 15 units, 1-5. Okay, physical chemistry 1-5. And inorganic chemistry 13 units. Okay, they have made this many pages syllabus. Okay, before there only 1 page syllabus were there. So now there are, I guess, how many pages were there? 3, 4, 5, 13 pages syllabus. See, now the syllabus is in 13 pages. So we have 13 pages syllabus. Correct? Initially it was only single page syllabus. So now you have to be more careful. Okay, and then do regular classes and do practices. Everything will be perfect. Okay, now once you're done with this jotting down, let me know. So I'll conclude today's class. Okay, and then again we will see the next class, how we are completing this hydrocarbons unit. So this hydrocarbons unit we will complete it. Not much tough. It is a quite easy only. Okay, this will get completed. So I think 1 or 2 classes this unit will complete, and then we'll directly go for one inorganic chapter. Okay, one organic, one inorganic, one physical. Again we'll come back to the organic, inorganic and physical. Correct? So have you done? Have you completed to jotting down this? Because I need answer by evening. Correct? By evening you send it to me. Okay, by evening you just send it to me whether this is aromatic, anti-aromatic or non-aromatic. So that I want to know. Correct? Have you completed? Or any particular question if you have, you can ask me directly now. Okay, I am available now. It is only with your reply only now I will discuss. You just tell me, because from my side I have done for today's class. If you have any kind of doubt, you may ask me. Okay, I'll clear it. Tell me any kind of doubt if you are getting. Yes, so have you completed writing down? See, this class will be available in a recorded E and F, sir. E and F. E and F, just write it down. See, this is nitrogen, okay? This is nitrogen, double bond, alternate double bond, alternate double bond. F, this is nitrogen, double bond, double bond. Don't solve now, okay? It will take time. You just solve it and send it to me. Whether it's a wrong or right, that we will discuss it, right? That we will discuss it. You just draw it and keep it right now. And in your free time, okay, you just go through it. Okay, what all possibilities you will find it. Based on that, you just say whether it's a aromatic, anti-aromatic and non-aromatic. And then we will discuss it that where we have to work in on. Like how to improve your concept. Okay, so that's why I have given this few questions. So based on that, I'll just modify the classes. Okay, so you are sitting over there, right, and I'm standing over here. So how we will come to know whether you are understanding or not? By solving few questions, right? If you are able to solve all the questions, means everything whatever I have said, you have grasped it at least 85 to 90%, right? I won't say 100%, because again you have to see this video, then only you will be closer to 100%, but no one can get 100%, right? So now your job is to do all the exercises and upload it to my chat box in app, GChem classes app, or in my WhatsApp number, right? So now for today's class, it is concluding. So thank you very much. Next class we'll see. Before that, you just upload this class, upload these examples. Okay, so thank you very much.